Hello everyone, my name is Dipali Kulshrestha. I'm AWS community builder and community leader for Delhi NCR community. And I also have Sandip with me. So Sandip, please introduce
Yeah.
yourself.
Hello, everyone. Welcome to this session. I'm Sandip Das. I'm AWS Container Hero, as well as I do teach about DevOps, cloud, and other technologies. So, welcome to this session. And we will, in this session, describe about the ECS, what it is, what AWS ECS is, how it works, and more on that. Dipali?
Yeah, so basically we are planning it as a series of container concepts. So in today's session, we are going to cover ECS concepts. So Sandeep, maybe you can carry on
So,
with
yeah.
the
So,
slides.
of course, definitely. So, let me explain one by one what ECS is and everything. Let's get started. So why actually containers? So we have to, before even moving to ECS or any other services, we should first say that why will we need any kind of container service? So we develop services, applications, APIs and front end application or whatnot. And sometime when you develop our machine, maybe some other developers also want to work on the same project. And if we give them our project codes, that might not work in their machine, right? And they will say, why? I mean, but it work on. I mean, you will say it work on your own machine, but it's not working in their machine. Because your environments are different. You could be in a Mac, you could be in Windows, and they could be in Linux or other OS. Okay, that's how this kind of issues happen. Now, why container? While using container has its own OS, and it doesn't matter from which platform to which platform you move, the containers OS is the same, and that is the reason no matter where it's done, it should run exact same way. And not only that, container has more features. We'll be just explaining, while we're going through. So how we actually go with the containers? So to do containerization, we have a lot of other services, and out of them we use Docker, which is the most popular one. Now, containers, what is, and again, let's go to the definition way. What is a container? As I told, containers are a method of operating system virtualization that allows you to run application and its dependencies in a single resource isolation process. What that means, it simply means in a container you have your application. Container has its own OS specifications. It has all the dependencies that required to run your application, and that's why it doesn't matter when it's done, because it's have whatever be there already. Therefore, it should be running fine. And so containers allow you to easily package your application source code, configuration, dependencies in easy to use building blocks, and that deliver environmental consistency, operational efficiency, developers productivity, and version control. We'll be learning all that in future sessions, but this session just focus on what is container. It simply means bundling your application and running is a platform independent way. That's the easiest way you can definition possible. Now you can see the diagram what we're doing here. You can see the front end, the from dev, you make your codes, you have your application, then there is containers engine, then any OS, be it Windows, Linux, and you can run it in anywhere. Okay. Now, what is a traditional virtual machines versus the containers? You can see in traditional virtual machines, you have physical server, then above that hypervisor, and then above the virtual OS, and inside that you have Bean libraries, and then your application running. And in this architecture, you'll see from OS to OS, your dependencies will be need to require installations. All the setup need to do it again and again. But if you think about the containers, you have physical server, you have operating system, then the Docker image, and then the container. And that container already have your OS, your binaries, your dependencies, whatever it actually needed to run the application. That's why it doesn't matter whatever OS is there, it will work in any OS if you have the Docker engine running there. So now benefit of containerization. You have microservices, we have hybrid applications, we have application migrating to cloud, batch processing, machine learning, and platform as service. Let's think about the microservices. So each developers develop services, and that could be have different requirements. There could be different environmental requirements. Now, what is the microservices concept coming in the containerization? Because you can just simply run your own application in a container and trigger it by any kind of URL. You can use a trigger as a URL like API call, or you can use the any kind of system call to trigger that services. And that way, you can have multiple Docker applications running, which will be running any kind of services in between this container, and all the containers are isolated. So you can have that kind of microservices application which is required here to make sure that all containers running fine and all are isolated. That way you can run microservices. Now hybrid applications. So hybrid applications where you might actually like I can give example like one in an application you have some code that is running on Go, you have some code running on PHP, or some code running on Node.js. If that is such a requirement, you can simply like containerize all the applications, and then you can trigger whatever is actually the code required based on the URLs or maybe whatever function you want to call. You can do that. Then application migration to cloud. Again, think about that. If you have like you are running in a Mac OS, you have installed dependencies, but that dependencies is based on the Mac computer. Now if you go to Windows, then dependencies will become different, right? And if you then think about moving to the cloud, again you are like you have to repeat the same thing in the cloud based on the cloud OS. Now what is the best benefit here? If you do container application, that means you are already, that container already have the source files, the all the dependencies. You just simply need to run in the cloud, and that's make this entire process easier. So that doesn't, you don't have to again reinstall anything. You don't have to kind of you don't have to do any kind of tweaks to run the application. Okay, that's easy how it is. Batch processing. So suppose you have kind of multiple data. Say suppose you have millions of data, and that data you want to process, and you then and the processing might need some kind of specialized software, or maybe the compilation of some binaries and all that. Now if you want to, then you can run multiple copies of simple Docker image or any kind of container image and run the process, and you may add as much as needed containers, and when you're done you can just kill the containers. That way batch processing a lot easier here. And now we already know that in machine learning, this kind of container concept are becoming very popular. And platform as service, Docker, you can run any kind of application. That's open up kind of platform as services in these days. Now, why containerization on AWS? Think about AWS is the number one place for run containers, and 80% of all containers in the cloud run on the AWS. Now, that's a very important point. Secure. AWS offers 210 security, compliance, governance services, and key features, which is about 40 more than the next largest cloud provider. Okay. Now, reliable. AWS container services run on the best global infrastructure with 69 availability zone and across 24 regions. Choice. AWS container services offer broader choice of services to run on your containers. So what it means that you can, like the next point, deeply integrated with AWS. AWS container service are deeply integrated with other AWS services by design. That allows you container application delivers the breadth and depth of AWS cloud for networking, security, and monitoring. So what this means that the last 2 points, that if you are running a container in AWS using the connection services, you can easily access other services from that particular container. You just, what you have to do, you have to add the role and access to the particular container, and it should be able to do that. Okay. Now let's think. I mean, we are talking about containerization on AWS. Now, what are the services available? There are multiple services: AWS ECS, AWS EKS, AWS Elastic Beanstalk. One of them, the most famous one, will say AWS ECS. Now, what is AWS ECS? AWS ECS, or Amazon Elastic Container Service, is the AWS Docker container service that handles the orchestration and provisioning of Docker containers that makes easy to run, stop, manage the Docker container on the cluster. So basically, what you have to do, you can just create a cluster and define what your requirement in the task definition. We'll be coming and discussing in greater depth there. And there you just mention all the environment variables, the image that will be running in the container and everything, and then you just simply run the application in the ECS. That's how easy it is. And the next thing is serverless. ECS support Fargate to provide serverless compute for containers. Now, ECS Fargate is a very important feature here. Suppose you have application requirement that need to be done for 2 hours or 3 hours in a day. In such cases, there is no point of having a EC2 instance running in a ECS cluster, and you have to pay for 24 hours into 30 days. So that's not make sense, right? I mean, you only need only 2 hours and that's it. In that some kind of cases, AWS ECS Fargate is extremely useful, where you can schedule like that to run for 2 hours and then stop it. Secure ECS launches your containers in your own Amazon VPC, allowing you to use your VPC security groups and network ACLs. Optimization for cost with ECS, you can use AWS Fargate Spot Task or ECS Spot instances to realize up to 90% discount compared to on-demand prices for running the stateless and fault-tolerant applications. So if you want to, you can run ECS on Fargate to save cost, or EC2 spot instances in a ECS cluster to save the cost. How ECS? I mean, we talked about ECS a lot, right? So how ECS actually works? So no, AWS have a service called ECR. This is the one where you will be storing your image like a Docker Hub. You can, for example, you can compare to. So instead of Docker Hub, we'll be utilizing ECR, and where we'll be storing the image. From there, it will come to the Elastic container service. There is multiple units. I'll be coming shortly. One of that is task definition. The task definition, you'll be defining how your application should run. And what is the mode? I mean, what is the network mode? What is the name of the that task? What is the container it should be running? So all the definition you put in the task definition, and then you run in either on EC2 or in a AWS Fargate, and you manage the containers. Okay, now ECS terminologies. In ECS, you have ECS cluster, you have task definition, you have task, you have service, and task definition versioning. So let me explain all that. So one by one, so you'll get to understand. So let me share the ECS, the AWS console. So you might see that once you log in AWS, you will see the screen. There you have to go to ECS, that is Elastic Container Service. Now I'll explain. We saw that ECS cluster, task definition, task service. So I will be explaining one by one what are those. So if you go to ECS, if you see this is a cluster. There you can go and create cluster. While creating cluster, you have three options. Networking only for Fargate, you have to use it. ECS, EC2 plus Linux plus networking, and EC2 Windows plus networking. By default, we'll go with this EC2 Linux. In mostly cases, you will be running Linux. But if you have the requirement to use Windows, you can go with the Windows. So let's go with EC2 Linux. Then you go to next step. Then you define the cluster name. Remember that I have shown that, I was showing that cluster. So this is the cluster. You have to give the name, say sample cluster. And then you have to select either spot or on demand. So if you want to save cost, you can go for the spot instances. But if you, you have to keep it running, you are not going for the spot, then you have to select the on demand instance, and then you have to enter what is the cluster size should be. So let's go with T3 large, for example. Number of instances. So how many instances or resources you might need? Think about your actual existing application if you're running one, or you may go with simple one instance if you don't have the idea what might be your actual requirement. Then EC2 AMI ID, let's go with the latest version 2 AMI. Then the volume, that is the how much storage you might require, that part. If you want to SSH, you can give your key, otherwise go with the non SSH. Here you can select the networking part, VPC. So if you have your VPC, like any existing one you want to use, you can select one, or otherwise if you want to like make a separate, you can go with the create new VPC option. And then this is a role. So that cluster needs some role. If you don't create, it will create for create newly. Okay. Enable container inside. If you want to get container, how much memory utilization or all these features, you can see it here. Create. And this is the cluster getting created. So this is the cluster I was talking about. Next, we'll be talking about the task definition. So let it be here the task the cluster to load first. And in that time, let's go to ECS service again. And you can see here in the left side, there is an option called task definition. So this is the task definition. Task definition defines exactly like it's a blueprint application, describe how a Docker container should run. So if you just, I can simply show you. So first, either is it task definition for a Fargate or EC2. Okay, here is EC2. Let's go with that. You have to give the task definition name. Say sample application. Here the required compared to EC2 task role. You can, if the tasks require particular permissions to access, I mean some kind of, you may want to send email, for that Amazon ACS. If you want to access the S3, then you have to give a role where you can have the S3 access. Similarly, you have to assign the role accordingly. Network mode, you have four options, that bridge, host, AWS VPC, or none. If you don't want any kind of network connection, then go for the none. If you want that to like this particular like container that will be running to use existing bridge mode, then go for bridge. If you want the networking interface of the host, that is the actual EC2 is running, then you go for the host. And if you want like a very separate one, elastic networking interface, then you go for the VPC one. We'll go with this default and my bridge. Okay. And the task execution role. The role required to task the pull container images and publish container logs to Amazon CloudWatch. So let's go with the ECS task execution role. Here it should have at least the ECR access and the CloudWatch access. The task size, you can say that your application, that container, how much memory it should be utilizing and how much CPU utilizing. So let's say 1000. And here units are very easy. So 1 GB means 1024 MB. You can say like that, or you can say 500 MB. How much MB is required, or you can simply say 1 GB. It's up to you. Let's go with the 1000. And CPU unit. Here you can mention the CPU unit. So one, like virtual CPU unit, it could be 1 CPU. Suppose it's a 1 CPU unit, it could be 2 CPU. If 2 CPU unit, like 2 vCPU. But if something like 500 CPU, in that case, you can say 500. That's it. Okay. And then the container. This is the main, or I will say important part of the this task definition, where you will be saying exactly how your container should run. So, for example, what should be the container name? Let's say sample container. What should be the image? You should be pulling from giving the image URL from your ECR. I will just simply show after a while what ECR is, or maybe let me show at the moment. So go to ECR. First go to Elastic Container Service, and if you see there, there's a repositories, that is the Amazon ECR. Let's see if I have any sample image. So I have this hello world while giving some demo. If you click on here, you will see here copy image URI, copy that, and then go to task definition, create task definition for EC2, or forget is based on your requirement. Now here adding the container part. So container, give the container name, or you can say hello world container, and there you give the image URL. Then you give the hard limit. Hard limit means that particular container cannot go above that limit. So if it's 300 MB, then it cannot use the more than 300. But if it's soft limit, it can. So based on the limit, it will be utilizing. So soft limit 500 MB for the particular container. Port mapping, you can say like if you need dynamic port mapping, you should use 0. If you need particular port to be running in a particular container, you can give the exact port number like this. It's up to you. Health check, you can mention here. Environment, you can say how many CPU you need. If it's a GPU supported instance, then you can give GPU units how much should be needed. Is it essential or not? What should be the entry point and what should be the command? If it's the entry point or command, you have according to your application need, you should be entering here. What should be the work directory? The environmental. If you can two-way give the environment variables. One is via the environmental file using S3 ARM, or you can just manually input all those here. Here also one more important part. You can just give value or value from. If you use value from, then you can give from the value from AWS parameter store. Okay. Here the container timeouts, the networking part you can manage. If you want the container to container networking, you should be mentioning here. Here you can go for the logging, and you can enable the logging, how the logging should be happening here, and all that you can add it. And if you just create, it will create a task definition for you. That is there. So let's say create. We have task definition, sample task definition. If you go to cluster, if you remember the cluster you had created, that sample cluster. This is the cluster. Okay, and cluster is a group of EC2 instances. If it's a EC2 instance, otherwise just a name where you should be mentioning your applications, all the services, the tasks, it should be running there. Now think about the service. Now what is service? Service is grouping of tasks which will be running at a particular point of time. So what that means, that suppose a service need 5 tasks to be running, and for some reason the load increased based on the auto scaling, the load will be increased. But at least if you mention that 5 minimum should be running, one in case of any one task dies. Now what is task? Task is simply mean running of a task definition. If you see simple, go to run task, and you have to give a definition, a task definition. So running a container, in easy language, running a container. And what is service means? Service means like like a grouping of the task to make sure the service run fine or your particular web service work fine. So if you go and create, you will see your launch type CEC2, the sample app, sample task definition you created. Then what is the cluster it should be running? What is the service name? Say hello world app. Then you have to say how many replicas need to be running. Say one. Then healthy percentage, maximum healthy percentage. The deployment circuit breaker for now is disabled. If you like any kind of problem happens in the deployment, we want to roll back, you can say how the rollback should happens. The deployment type, it should be rolling update like one by one by one, or it should be a blue green. So completely different. Like it's a DNS level change will happen, or complete another environment, all the resources will get created and updated, and then the DNS level just replace the DNS with the current instances. That's how it managed. Task basement is it should be spreading across all the ability zone, or it should be balanced based on a spread over across zone with a particular where the memory is higher, or just purely based on wherever the memory is higher, or one task per host. You have to define how you want to place your task here. Then the task configuration, and then if you go to next step, just go to next step. You should be they will be asking about the VPC, how what subnet you want to provide, the security group, auto assign public IP should be there or not, and then come the how you want to, like do you want to add load balancer or not. You can have application load balancer, network load balancer, or classic load balancer. Based on your requirement, you should go with what the load balancer you want. Mostly everyone go with the load balancer. You give the load balancer URL here, and then go to next step and do that. Let's go to so let's see if I have any VPC where you have the load balancer there. So I can just simply show how to do that. Okay, so I've just changed my VPC. Let's see. Click on now. If I go to application load balancer, I should have one load balancer at least. Okay, yeah. So I have one from demo. There you have to add the port mapping, the like from which port to which port should listen. So port 80 to port 80, and there you can like how the health check should happen. It could be root. If you have particular doubt like this, mention in your codes, then you can just call that a particular API. The next step, so just give it path matching, it should be fine. Next, do you want to that configure the auto scaling or not? Here you can give like how what should be the auto scaling, and what should be like role for the auto scaling, how you want to auto scale, like high CPU, and give what should be like more than 80% of CPU usage. You are going to create a new instance. Next, and that's how you want to create a service. Okay, so now I have covered what is the task definition, what is task now, and all that. What is a cluster? Now Dipali will be giving a good demo on how the ECS actually works. Up to you, Dipali.
Sure, Sandeep, thanks. So I think by now you understand that exactly what ECS concepts are and exactly what kind of configuration we can do with ECS. So now let's see a quick demo uh, to create a simple application from scratch and containerize it via ECS. So I hope you can see my screen.
Yeah. We can see it still.
Okay. Okay. So far you understood the ECS concepts, that exactly what are capabilities ECS provide and what level of configurations you can do to containerize your application with ECS. But now let's see step-by-step process to create a simple application from scratch and containerize it with ECS. So here, if you look at this Medium blog, here we have listed all the all the step-by-step process to create one application, one simple Hello World application in Node.js from scratch, and then we will containerize it with the help of ECS. So for that, let's start the process. So definitely we need a machine. So here I have launched a simple EC2 machine, the T2 micro kind of. So let me just open our active session here. So we are going to set up everything on this machine from scratch. So first of all, since we need to create container image, which we can really push into our ECR repository, which our ECS can use. So for that, first of all, we need to create Docker on our EC2 machine if it is not already available. Since I have just created this EC2 machine and I know Docker is not installed there, so here are the steps to install Docker. So first of all, we will take the updates. Let me close this window. And after that, we can run the simple command yum install -y docker to install the Docker. And once Docker is installed, we can start the Docker service. So I'm simply copying pasting these commands so you can exactly follow the same steps to create your first application. So now we have started the Docker service, and with this command, we are actually adding this user, Docker user, EC2 user into the Docker admin groups. So it has all the required privileges which are needed to create the Docker image. So once we have added this, then we need to log back in so that it has all the required access. So I'm exiting and then I'll log in again onto this. In order to log in again, let me just grab the public DNS of this particular instance. So this is the instance which is running. So I'm just copying the public DNS of this. So I have launched this instance with this key pair. So with that, I'm logging in with the same EC2 user. And now this user has all the required privileges. So if we go back to our steps, we can check, just ensure that Docker is installed properly. So we can check the Docker versions. So yes, now we can see Docker version 19 is there. So means Docker is installed there. Next step, as we are going to create Node.js application, so we need to set up Node.js on this machine. So in order to set up Node.js, we can follow this AWS documentation. So how to do that? That first of all, we need to connect to our machine, and then in this step, what we are doing, we are installing NVM. So let's simply copy paste this. So once NVM is installed, then we need to activate the NVM. And after that, we need to install the node. And once node is installed, then we can check the node version by running this command. So far, we have installed Docker, we have installed node. Now, next step for us is to really create our application. So let's see. So in the third step, we are creating one directory, and in that directory, we'll create our application. Though you can create your application in the root directory itself, but it is a good practice to create your application into a separate directory. So with mkdir, I have simply created this directory named hello world. Then I'm sorry, I copied the same command. And then with cd, I'm just switching to that directory, hello world. And then here I will initialize the npm. So it can create a package.json for us. So package name, yes, I'm fine with hello world. I'm just going with the default options here. So with this, we have initialized the npm here. Now, next thing, we are installing Express because we will be using it in our application. We will use this particular library into our application. So hence, we are installing this Express framework here. Now, let's create our application file index.js. So it will create a blank index.js file where we will write that exactly what we want our application to do. So I'm simply doing like vi index.js. So I can provide my application code here, which is given in this step file. So what this code is doing, that using Express, and that's the reason we installed Express earlier, then I'm defining that this is the landing area of my, this is the landing page for my application where I'm responding in this text, hello world. So whenever I run this application on this particular port, 8081, it should show me hello world. So this is the simple hello world application via Node.js. So simply provide this code in here, save the file, and next step is to run your application. So how to run node application? Node followed by your application file name. So it says that application is listening on port 8081. So how to check that? So as of now, like we have not done anything on the container. What we have done, we have created one Node.js application on local machine, which is EC2 in our case, and we have actually started that application on local machine, and now we will see that if it is running, if we can see that application running or not. Then how we can access via public DNS of this EC2. So if I provide the public DNS followed by the port where we have coded our application to run, which is 8081, we should see hello world. So there you go. So means this is the good practice. This whenever you're creating any application, test it at your local, and when everything is fine, then you plan to move it on to the containers. All right. So here I have just stopped this application. Now let's follow the next steps to in order to containerize it. So what we need in order to containerize it, that first of all, we need to create a Docker file, because Docker file is something which will create the image for this application. So how to create a Docker file? Its name is going to be, I'm just simply copying this code here, and we will create a file named Docker file, and provide this code here. So what it is doing, we are taking a base image of Node version 7, and then we are defining our working directory as app, and then we are copying our package.json, the npm which we initialized earlier, and then we are running npm install so that it can run every dependencies which is listed here. And then we will like copy whatever is there in the app directory. So we'll copy our index.js, and then we will run our index.js using this command. And then in Docker file, we are exposing this application on port 8082. So at our local, we exposed this application on 8081, while for container, for this image, we are like exposing this application on 8082. So let's save this file. So here we are done with creating Docker file. Now we need to create an image out of this file, and we need to push that image into the ECR, which is Elastic Container Repository. So for that, let's go to ECR and create a repository first. So we simply, this is the like ECR dashboard. And in order to create a new repository, we can like choose whether we want a public or private repository. So I'm simply saying like repository name is like hello repo. That goes well with this demo. And rest everything I'm leaving default. So here it has created a repository, and if you open this, as of now, there is no image, right? But now if you click on this option, view push command, it will give you all the commands which are needed to push image into this repository. So we'll follow these commands one by one. So I'm simply copying this first command here, and so what it does, it will log in. It means it lets us log in into this ECR console, and then we need to create image. So the Docker file which we have created, it will use that file and it will use this command docker build -t, and then it will give this is the repository name and then followed by a dot. So with this command, we can create a image for our application. So meanwhile, when it is creating the image, let's understand the next command. So in this third command, what we are doing, whatever image is created here, we are tagging that image as latest. Okay. And once we have tagged our image as latest, then we will push this image into the ECR repository. Okay. So let's copy this next command here. Like it has successfully built the image and it has tagged as well, but let us tag it again with the tag latest. Now let's push this image using docker push command to the ECR. So as we notice, like initially our repository was blank, there was no image, but after this processing is complete, we should be able to see one image into that repository. So far what we did, like we set up our machine, and for that setup what we did, we installed Docker, we set up the node on that, and then we created our application. We tested that application on local as well, though it is not really required, but it is a good practice. And then we created a Docker file, and post that we created one repository, and using the view push commands given at the ECR console, we have created the image, and now we are trying to push that image into the repository. So there we go. It has completed. Now let's see. Let's try to refresh this. So here we can see that it has pushed one image with this tag latest. Okay. So now let's see what is the next step. So we are done with this step 8 here, that we have created ECR repository hello repo and created and push image via view push commands. Now in the next step, we really need to move on to the ECS, where we need to create a cluster. So if you recall what Sandip Sandip told, in ECS cluster is nothing, but it is a place where you are procuring the infrastructure, where you are procuring the machine where your container can run. So let's go to ECS here. So here, let's go to clusters and create a new cluster. And since we have created our application on Linux, I'm going with this EC2 Linux option. So you can create cluster for your Windows applications also. Here we need to give some cluster name. Since it is a Hello World application, I'm simply saying like Hello Cluster. And most of the things I'll go with the default option, but yeah, instance type, because it is something like it is a differentiator for your costing, for your billing. So since we are dealing with a very small simple hello world application, let's go with some small instances here. Let's say like T2 small or something. Yeah, let me see. Take T2 small, and I'm just creating one instance for this demo, but yes, you can create multiple instances in one go. We can either create this into a new VPC, or we can use our existing VPC. It's totally up to us. Let's use our existing default VPC here. Choose some subnets and security group. So here either I can create a new one or I can use the existing one. So here I'm using this existing one, and I'll tell you the reason why. Rest everything I'm just leaving default, and I'm creating this cluster. So while it is creating the cluster, let me show you the security group, why I have picked this particular one. So in for this EC2 instance where we had tested our local application, so if we look at the security group of this EC2 instance, so here I have opened that code 8081, and that was the reason I could run that application on my local machine. So if I have not opened this port 8081 here, it won't allow me to access this application onto the local machine. And in my Docker file, I have opened port 8082, right? I have like exposed port 8082. And so all both these ports I have opened in this security group. And that is the reason I have picked this particular security group for my container. So I really don't need to fix the security group again. All right. Now let's go back to ECS. So it has created the cluster. Let's see the cluster. So yes, so means once you have like machine created, what is the next step? Next step is to define your application, and how we can define the application using the task definition. So as Sandeep mentioned, the task definition is a really a blueprint for your application, where you can define that exactly how your application look like, how it should launch the container, and this is the place where you will actually map your container information. So we'll create a new task definition, and we are using the EC2. I can go serverless by using Fargate, but for this demo, let's stick to EC2. We need to provide some name here. So let's say hello task definition. And you can create a new role, but just keep it simple. I'm leaving like these things as default, and I'm just simply going to add the container information here. So I need to provide a container name. Let's say hello container, and then here I need to provide the URL. So here is the URL. This is the URI of my container image. So this is like URL and followed by tag. So now we need to definitely define some memory limit here. So let's go for some soft limit, maybe 1024 MB. And this is the important thing, as Sandeep mentioned, that we need to provide a mapping that exactly what is the host port for your application, and in container exactly on which port you will be running this application. So if you recall, in our Docker file, we have exposed port 8082. So port 8082 is going to be the host port for my application. And in this container, let's run it at port 8081, because that is something we have already opened in our security group, right? Rest everything, let's leave default and add this container information and create this task definition here. So once we have created the task definition, means we have like initially when we created cluster, so we procured the machine, and when we created the task definition, we have added our application information is here, and now next step is to simply run the application. So if I'm dealing with multiple tasks, I can create a service, but since here I'm dealing with only one like task, so I can simply just go to this task definition and can run it from here itself. So I'm just selecting this task definition and simply say run task. How I want to run, using EC2, and rest everything is default, and hit run task. So it says here, if you notice the status, that desired status is running while the current status is pending. So we need to wait for a few seconds while our like current status comes to the running. So here it is in running status now. Let's open this and check details that exactly what are the like container details here. So you can see the mapping which you defined, that host port was 8082, container port is 8082, 8081, and this is the link to access your application. So if we simply click this, we can see that yes, our application is running this time via container. So overall, like these are the basic steps which you need to follow to containerize any application, whether it is like written in Node.js, Go, Python, anything. So what you need to do, you need to create your application, you need to create like Docker file for your application, and then you will create image, and then you will then you will create a ECS cluster, and in the task definition you will map your application image, and then you will run your task definition. So this is how we have created one end-to-end application. Like we have created one application from scratch and we have dockerized it. All right. And once you are done with these steps, please don't forget to delete your AWS resources. In this case, we will need to delete the ECS cluster, and we will need to delete a repository as well. And yes, we need to terminate our EC2 instance as well. So make sure that you delete these resources after you have experimented, so you don't get unnecessary bill. All right, hope it is useful for you. Just practice this and gear up for the next session with us.